just picking up where I left off from the last video, and what I would like to do is just run the general linear model again, but this time including more variables. So we were looking at the relationship between resilience and psychological quality of life. We adjusted for gender and year of study, but we've also got some other measures here that might be of interest. The BDI is their depression score, Beck Depression Inventory. I could put a label in there. Depression Inventory. Yeah, let's put the score at the end. Age, legal status, and school location, and we've got some anxiety measures here as well. Now the thing with age is there's going to be some overlap between age and year of study, so it's not necessarily sensible to include both of these variables. And so maybe we would look at this first just to see, are these two things essentially the same? So let's reset this and let's just do a box plot to explore that. And I want to look at, I've turned it into scale. Wait, let me, hold on. I'm going to turn that back to nominal. Sorry, ordinal. Just so I can do a box plot. Because I just want to see the range of ages in each of those years of study to see if these are different variables or if they're essentially the same variable measured in different ways. There's quite a range of ages. That's actually more than I was expecting. So the bulk of the ages, we can here see the middle 50% here are in their first year of study around the 20. Is there someone that's really young? And then obviously you're going up as you go through these years of study. Although this is a cross-sectional study, we would expect that you are older in the later years. We're not following people as they track through. But there is actually a lot more variation here, I think, than I was expecting in the ages. So let's have a look at how we might run a general linear model with more variables. I know watching in the workshop, some people seem to think that it was always the main explanatory variable of interest had to go in the covariate box, and it's not whether or not it's the main explanatory variable of interest, it's what type of variable it is. That's what drives which box it goes into. So I want to show you a model where we're basically putting more stuff in and working out which boxes they should go in. So we were using this as our outcome, so I'll just chuck that back in, and our resilience I was using as our main explanatory variable of interest, and then we were controlling for some of the demographic information. So in the general linear model, we'll leave those. Now it's picked that up as, we better reset that so it can recode it. So let's have a look at, so our main outcome, I wonder if I can make this bigger. So fixed factors are any categorical variables that we want to include. So let's include gender, a year of study, legal status, and school location. So technically this might be a random factor, but we're not going into this. I'm just going to put everything into the fixed factor box for simplicity. If you're doing an advanced course, then you can look into what random factors are. Now the covariates are any explanatory variables which we're treating as continuous. So in this case we're looking at resilience, but we could also look at depression, and let's put in the anxiety scores. Now, I don't know enough about these different measures. I'm not an expert in these areas, so I don't know what kind of overlap there is between these different scores. And I'm going to try putting in age, even though there is some overlap between age and year of study. I'm going to leave that as the full factorial model just to show you what will happen if you've got a lot of variables, and then we might come back and change some things there. So I press OK. So if we take a look at this output, and maybe this is time to get my pointer out. So we can see we've got all of the primary variables of interest and what we call their main effects here. And then we get an extra line for all these interaction effects. Now, this is quite a lot of interactions to test for. In this case, it might be okay because the data set is really large, but in your projects, you've probably only got 30 to 50 data points, and you just won't have the power to look for all these different interactions. And so if you do have a lot of categorical variables of interest, you don't want to include all these interactions by default. So let's just double check that we know how to take these interactions out. I'm just going to have a quick look through here and have a look at some of these significance values. So the age is significant, and that year of study might also be significant. And I wonder if there's an interaction between age and year of study. Oh no, it won't have included that by default because that's continuous. So let's take out some of these interaction terms and run that again. You'll notice that the R-squared value here is much higher, but that may not change much once we take out all these interactions. And simply getting a higher R-squared is not always better if you're doing what we call overfitting the model and essentially having too many variables in there. And that's when you really want to start looking at the adjusted R-squared instead, which sort of accounts for that in a so we're going to go into the model. Let's build the custom terms. Let's select everything, build terms. I think this might be new for this version of SPSS. We're after the main effects. So the main effects means we're just looking at the effect of each variable controlling for the others, but not looking at any interaction effects. Continue. Okay. And so we can see here that we've got much less output because we don't have all these interactions. And if we're looking at how much variation in this cycle, in this outcome, we can explain with our model that actually hasn't dropped. Actually, is it the same? It's just about the same. So, I mean, those extra interactions were really not contributing very much to the model at all. Now, if I was going to refine this model, I might go through and have a look at whether or not the variables were significant and whether we really needed them to explain what was going on with the psychological quality of life. And it really looks like legal status is not having, there is no difference based on legal status. So let's take that out. Oh, it might want me to take it out of the model. Hold on, I'm just going to check what it's included. Yeah, it messed this up because I took out the thing. And it really looks like there is no difference between the gender, year of study, and school location. Now, this is interesting because before we did see a gender effect. So the question is, what's going on here? And the reason is because we've changed the model. In the first model, we were only looking at the relationship between the psychological quality of life and resilience. Now that we've adjusted for the depression score and the anxiety score, there's naturally no difference between the genders. So that probably means that gender was acting as a proxy for anxiety and depression, or some combination of those. Now, I'm not an expert in this area, so I really can't interpret this data too heavily. I'll just move this here. So we can see that the depression and anxiety scores are highly significant and age is significant. And now that the gender is not significant, that's a high p-value. So I'd probably take that one out next. Maybe I should do it through the model so it doesn't get all confused. Let's take that out, continue. I'll take it out there too. And the school location doesn't appear to be important. Now you might be thinking, this is taking a long time. Well, there are some automatic ways of doing it, but I think if you're getting started, it's good practice really to do this by hand. I should have done it in the model first, shouldn't I? Because you want to keep an eye on what's going on and checking that you're thinking about what's happening and whether or not each step is sensible. And now it looks like if we've adjusted for age that the, sorry, grab my pointer. I had too many windows open on my computer. So now that we've got our model refined here, age is still significant, year of study is not, and so we should probably just include age and take out this year of study. So last modification, general linear model. I'm going to take out year of study. And now we're left with a model. This is essentially just multiple regression. We don't have any categorical variables in here at all now, which is fun. And if we look at the R-squared, how much variation in this outcome we're explaining with our model, that's staying about the same. This hasn't changed, and that's because these insignificant variables were not contributing anything to essentially the prediction. They weren't making the predictions for psychological outcome any better. It wasn't making a better fit for understanding the relationship between these variables and psychological outcome. And so this amount of variation explained is not changing much because they weren't helping explain anything. So this would be probably the final model that I would report if I was reporting on this data, and this was my research question. I might report the starting model. Where's the starting model? Maybe not that one with all the interactions. Maybe I'd start with this model and I might report, perhaps rather than the F statistics, it would be more intuitive to report some parameter values and then the final adjusted model. Just because these p-values can all change a little bit when you're taking variables in and out, it would be best to report the final model as well rather than just looking at that one. So now that we've got our final model, I would definitely do a residual check now, and if I was doing this for real, I probably would have done some residual checks along the way, especially because all of these measures are continuous, and so I would be wanting to check if there was any curvature in the data, because we're assuming that there's a linear relationship between each of these. So what I might do is just go through that process of getting the coefficient values out that I might use for making a table and checking the residuals here. So if we go back into this option, we can save our predicted values, and I'm going to save the standardized residuals. In the other video I also saved these, but that was just to show you where the errors are coming from, what they mean. I'm going to use the standardized ones. And then for the option, I'm going to save the parameter estimates. If you did read up on effect sizes back in, I can't remember, maybe week 5 or 6, you could also have a look at that. And it will do some tests automatically for you, but I recommend that when you're learning to do this, you do some of these plots by hand so you really understand what it is that you're doing. Okay. So now we've got our parameter estimates, and these would probably be what I would report in a table with the p-values. And the effect sizes, so you can look up how to interpret the partial eta squareds as an effect size. And what's of interest here is whether the association is positive or negative. So it's saying that the intercept, or like the starting value for psychological health, is about 80. I think, is it out of 100? Is that how they scaled it? And then you get a little bump upwards for every extra increase in resilience score, and you get a little bump downwards for every increase in depression, anxiety, and age. Isn't that interesting? So the psychological health seems to be going down with age. I hadn't thought about what direction that my relationship might go previously, but that's what it looks like it is. Although, having said that, where's my pointer? They're all highly significant, but if we look at the effect sizes, and you can see this as well in the parameter estimates, just don't mind my dislocated shoulder there, that this is the smallest effect size. So what seems to be having the biggest impact on the psychological health is this depression score and then trait anxiety. And I don't know the difference between state anxiety and trait anxiety. Someone can tell me and educate me about that. And then going up for resilience. But this is having, the depression score is having the biggest effect here. So now in our data set, we have our residuals. Oh, that's not the one I wanted. So we've got our predicted values and our residuals. So I'll quickly do a few graphs there. Let's see if there's any outliers. And there's a few either side, but this was a massive data set, and I'm not too worried about these. I don't think these will be having too much of an influence on the result. In any case, they're fairly balanced either side. So then the histogram, and I think this is going to look fairly, yeah, see, that's looking fine. There may be a teensy bit of kurtosis, maybe a little bit what we call kurtotic, in that it's overly peaked, as if someone's pulled it up a little bit. But that, I think that's looking fine. And then the last graph, well, that we've been looking at in this course, and if you go on to do a more advanced analysis, you can do, there's a lot more graphs you can do to check for various things. We are going to have a look at if the residuals are randomly spread across the predicted values. So we're going to put the predicted values in the x-axis and our residuals in the y-axis, and we're hoping that they're just randomly scattered about. And we can put a line in at 0 because the errors or the residuals should be scattered about 0. So that's looking okay. We've got a couple of outliers that we saw. I'm not too worried about those. There doesn't seem to be a huge change in variance across the line, and I can't see any curvature. Really, if you were looking to see if there was any curvature in these, if you were doing a more advanced analysis, you'd be wanting to plot these residuals against each of the covariates. So each of these variables here, you would be plotting the residuals, and that would help pull out if there was any curvature in any of these. But we're not going to do that in this course. We're just going to leave it at those 3 graphs for the residual checks. And then in the answer sheet for this week, I will put in the table of results similar to what we did in the workshop so that online students can see it. And you can also look at some of the reading material in the reading research section for an example of how you might present the results for something like this. You can, of course, read the original paper that this data has come from, but they were not looking at specifically what we've just looked at there. I decided on a little research question just to look at one of these as an outcome, and they had a whole lot of other stuff that they were interested to around these. I can't remember what DREAM stands for. There's some kind of educational measurement, but I've just ignored those in this. Okay, post to the forum if you've got any questions, and let me know how you get on with your projects.